Yo, 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 here we are looking at section 5.3. We're looking at logarithmic as well as exponential functions and solving them and how we kind of write them to go back and forth between the two. And so in this first section here, we're just kind of restating things. And this is the main thing we're looking at here. A logarithm to any base of that same number is equal to this exponent. So that's what's kind of happening here. In the same way that we had to write our exponentials and both sides having the same base so that we could set the exponents to each other, same thing is happening here. So basically 4 to what power is 64 is what is being asked here. 5 to what power is 1, and so forth. Once again here, we're looking at writing this again. So here at log, base here is 4, so base will be the same thing for our logarithm. To what power is 16? So it's kind of, here we take this exponential and we're writing it as a logarithmic form, and that's a perfect example there. More of the same happening here. Here, once again, 4 to what power is 256? And here we have to do a little bit of solving in order to find the value of x. Once again, 3 to the negative 1 power is 1/3. More about going back in between exponentials and logarithms. And then here we get to the first time where we're looking at some basic principles of a log function. So we're just expanding this logarithm. Once again, you could put all of this into your calculator. Keep in mind that it will give you a decimal, so you have to convert that to a fraction. And then here, I'm just kind of rewriting everything. So we have a root power. It's the same thing as a fractional exponent. And then I bring that out to the front. So that is a rule of logarithms. Anytime we have something to a power, we can bring that out the front. Here, I want to kind of rewrite this. And so when we multiply things, we can add those logarithms of the same base. So 9 times 3. And then I rewrote 3 as 9 to the 1/2 power, or the square root of 9 is 3. So 3 times 9 is 27. So I just made that change, and I'm using this law of logarithms. And then, as we saw earlier, log base to the same thing is 1, or this exponent. So 1 times 1/4 is 1/4. Here, the exponent is 1/2. So 1/2 times 1/4 is 1/8. So that's where those numbers came from. And then I rewrote 3 as 9 to the 1/2 power, so I have the same base here, so I could say that this reduces to 1/2, and then I just combined. Here, base to a logarithm of the same base is equal to that number. Same thing we've seen here earlier. Log base 10 of x is the same thing as log x, so this is understood. Same thing as the square root, we know that the root is 2. And then here, log base e power is a natural log. So when you see this, it's a logarithm. It's all it is. It's just with a special base of the irrational number e. And then same principle here, log base 10 of 10 is equal to that exponent. Same thing here, log base e of e is equal to that exponent. Log base e of e to this power, we have to multiply these two to get 43. So one thing we can do is just simply plug this into our calculator. Log of 50, log of 0.463, natural log of 75, so on and so forth. And here we're breaking this down. Since we're dividing, that means we are subtracting here. So keep in mind, same base, and we have log base 15 minus log base 6 of 7. Here we're breaking these apart, so we're multiplying on top, which means we are adding them. And we are subtracting what we are dividing by. As you can see, all of those have the same base. Same thing happening here. We're just breaking these apart. So rewriting square root of 5 is 5 to the 1/2 power, so I could bring that out to the front. Log base 7 of 7 is 1. That's what we've been looking at. And then we just need to distribute that negative. Looking at this one in particular, it cannot be simplified. Breaking these apart. Once again, breaking these apart. Breaking these apart again. Putting these back together. Here, we're looking at here, we're just basically, that's out front, so we bring it in as the exponent. We're adding here, so we're multiplying these two things. breaking these apart is using exponential rules. Putting these back together. And these right here, I didn't write it down. Let's do that right now. Some of your calculators are able to do this. Some, like mine, are not. So you have to put it to your calculator as log 11 divided by log base 3. Log 3. So the bases here are 10 for each of those, and that's how I was able to do this. Some of you are able to just type it in log base 3 of 11, and you're done. If you do not have that ability on your calculator, then this is simply how you'll put it into your calculator. And that's how you're able to simplify this.